morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In our subject Fluid Mechanics and Hydraulics, today we are going to study manometer. If you remember, then in last lecture we discussed simple manometer, piezometer and U-tube manometer. There are different types of manometer. Okay, piezometer and U-tube manometer we already discussed in our last lecture. Now today we are going to study U-tube differential manometer. Now as you remember, U-tube manometer, in U-tube manometer we connect a U-shaped tube. The shape of glass tube is U-shape. So we connect a U-shaped glass tube to the pipe where we have to measure the pressure. Okay, so basically manometer is used to measure pressure or pressure difference between two pipes, or in a manometer we connect a U-shaped pipe. That manometer is called U-tube manometer. Now today we are going to study a manometer which is U-tube differential manometer. Now as you can see in this diagram, in this figure there are two different manometers. Okay, the first diagram indicates there are two pipes, pipe A and pipe B. As you can see in the diagram, there are two pipes. In first figure, the pipe A and pipe B both are at different level. There is a height difference between pipe A and pipe B. This is your pipe A and this is your pipe B in figure number 1. Okay, and between pipe A and pipe B you connect a U-shaped glass tube. U-shaped glass tube. Okay, pipe A and pipe B both are at a different levels. Now in diagram number 2 we are taking two pipes, pipe A and pipe B, but in figure number 2 two pipes A and B are at a same level. Pipe A and pipe B both are at a same level. Okay, and also we connect a U-shaped glass tube between pipe A and pipe B. Clear? Now as you can see at bottom, which is indicated with dark black color, below XX, here below XX axis we filled mercury as a manometric fluid. Okay, this mercury we already discussed in our U-tube manometer. So any U-tube manometer, in that U shape we filled mercury because it is a heavier than water. Mercury is very heavy liquid. Its specific gravity is 13.6, which is 13.6 times heavier than water. That's why we use mercury as a manometric fluid. Okay, now at the bottom we filled mercury as a manometric fluid. Clear? Now U-tube differential manometer, where it is used. So in many cases we require the difference between two pipes. In normally if we required pressure difference between two pipes, either different level or at the same level. So at that place we use differential U-tube manometer when we have to measure pressure difference between two pipes. Here we are considering pipe A and pipe B. There are your two different pipes and we have to measure pressure difference. So we can find out pressure difference by using U-tube differential manometer. Okay, so in figure the 2 points, as you can see here, point A and point B. Here in second figure, point A and point B are at different level and also contain liquid of different specific gravity. In pipe A and pipe B there are different liquid with different specific gravity. So these points are connected to YouTube manometer. Point A and point B are connected to YouTube manometer, and the pressure in pipe A or pressure at point A is PA and pressure at point P is PB. We indicate pressure in pipe A or point A, which is PA, and pressure in pipe B, which is PB. Clear? Now, let's start our derivation. For that, just remember this. Here, pipe A and pipe B both are at a different levels. Okay, there is a level difference. Now, liquid coming from pipe A goes down, okay, and it applies pressure to the mercury which is placed at bottom. Okay, liquid from pipe A, fluid from pipe A goes downward, it applies pressure to the mercury, and mercury in U shape goes upward. So here, as you can see, H is a rise of mercury, because here applies pressure, liquid from pipe A applies pressure to downward direction and the mercury moves upward. So here H is a height of rise of mercury. Clear? H is a height of rise of mercury. So here, as you can see, H, that is a difference of mercury level. Y, in this diagram, distance Y is a distance of center of B from mercury level in the right limb. Okay, as you can see, Y distance here. Okay, X, small x in this diagram, X is a distance from center of A from mercury level in left column. Okay, now rho 1, that is the density of liquid at A point. Density of liquid in pipe A, that is rho 1. Density of liquid in pipe B, that is rho 2, and density of mercury which is filled here, density of mercury is rho G. These are the indications for the diagram. Clear? Okay. Now let's see. This is your diagram. Now taking datum XX, here XX, below this XX section the mercury is filled. Okay, so we are considering XX line as a datum line. Now pressure above XX in left limb. Remember, pressure above XX in left limb. Okay, so first pressure in XX, above XX in left limb, that is PA, pressure at center of the pipe, that is PA. Okay, now second pressure, as we know the equation for pressure, P equals to rho GH. Okay, now in left column the density is rho 1, gravitational force, that is G, and what is height in left column? In left column in pipe A, what is the total height up to XX? That is X plus H. X plus H. Okay, so pressure above XX in left limb, that is rho 1 into G into X1 plus H plus PA. Okay, clear? Now pressure above XX in right limb. Okay, in a right limb where there is a pipe B. Okay, so first pressure at center of pipe at point B, that is PB. So in a right limb the first pressure is PB. Okay, now in the right side there are two different liquid. first liquid with density rho 2 and second is a mercury with density rho g. So, first pressure due to this liquid which is in pipe B, that is rho 1 into G, sorry, rho 2 into G into Y. The pressure due to this fluid at XX is rho 2 into G into height, that height is Y. Okay. Now, this part, mercury rises. So, due to this rise, the pressure at XX is rho G into G and height is H. Clear? So, final pressure above XX in right limb, that is rho G into G into H plus rho 2 into G into Y plus PB. Clear? Okay. Now, comparing above equation we have, so here pressure in left side and pressure in right column must be equal. So, comparing both the equation, rho 1 G H plus X plus PA equals to rho G G H plus rho 2 G Y plus PB. These are two equations. Okay. Now, making PA minus PB as your subject, because here we have to find out pressure difference. So, PA minus PB is your subject here. So, PA minus PB equals to rho G into G into H plus rho 2 into G into Y minus rho 1 into G X plus H. So, this is a final pressure difference between pipe A and pipe B when both the pipes are at different levels. Okay. Now, next, in this diagram, as you can see, there are two pipes A and B. Now, here pipe A and pipe B both are at a same level. Okay. So, now pressure above XX in right limb equals to right column. See in diagram, first pressure due to center of pipe at point B, which is PB, plus rho G G into H plus rho 1 G into X. Now, pressure above XX in left column, that is rho 1 into G X plus H plus PA. Okay. So, now comparing above equation we get rho G into G into H plus rho 1 into G into X plus PB equals to rho 1 into G into H plus X plus PA. Now, making PA minus PB as your subject. So, PA minus PB equals to rho G into G plus H into H plus rho 1 into G into X minus rho 1 into G H plus X. So, this is a pressure difference when pipe A and pipe B are at same level. Now, here for this case, for this derivation, we taken a same fluid in pipe A and pipe B. As you can see in this diagram or is in derivation, the liquid of intensity, the density of liquid in pipe A is rho 1 and the density of liquid in pipe B is also rho 1. So, here it indicates that there is a same fluid in pipe A and pipe B. In this derivation, you can also take rho 2 at place of rho 1. Okay. You can take different densities or you can take same density. Okay. Now, our next type of manometer, which is inverted U-tube differential manometer. Now, as the name indicates, what is the meaning of inverted? Yes, inverted U-tube manometer is like this. Here, there is two pipes, pipe A and pipe B, and U-tube manometer is connected inverted. Okay, so that why this is called inverted U-tube differential manometer. Again, this manometer is used to measure pressure difference between two pipes A and B. In this diagram, there are two pipes A and B are at different levels. Okay, this is your U shape. As you can see at the top, there is a U shape where we filled manometric fluid, okay, clear? Now here it consists a inverted U-tube having two ends connected to the pipes at point A and point B, whose difference of pressure is to be measured. Now it is used for, now the places where we can use inverted U-tube manometer. So it is used for measuring the difference of low pressure. Remember then, when there are very low pressure difference between two pipes, almost negligible, at that time we use inverted U-tube differential manometer. It is not useful for high pressure difference. It is normally used for pressure difference very low between the pipes. Okay. Now let the pressure at point A is more than pressure at point B. So let's start the derivation. For that, understand this diagram. Here there is a pipe A and this is your pipe B. Now here there is a manometric fluid. A fluid from pipe A goes upward and it applies pressure at x-axis. It applies pressure at x-axis. So the manometric fluid goes downward in right side, and the height, that is small h. The height of liquid manometric fluid goes downward, that is small h. Okay. Height of fluid in left column, that is H1. Okay, as you can see, H1 is a height of liquid in left column below x-axis. Okay, H2 is a height of liquid in right column. Small h is a difference of liquid, difference of height of liquid, manometric liquid. Rho 1 is a density of liquid at point A. Rho 2 is a density of fluid at point B, and rho S is a density of light liquid or manometric liquid. PA, that is a pressure at point A, and PB is a pressure at point B. Now in this notations, the word is used which is light liquid. So remember that in U-tube differential manometer or U-tube manometer, we take mercury as a manometric fluid, but in inverted U-tube manometer, we are taking lighter liquid than water as a manometric fluid. Remember this, for inverted U-tube manometer, we are taking lighter liquid, the liquid which is light in weight than water, as a manometric fluid. Example like oil, kerosene, which are, the specific gravity of oil is 0.8, specific gravity of kerosene is 0.74, and the specific gravity of water is 1. So here we are taking the liquid which is lighter than water as a manometric fluid. Okay. Now let's start the derivation. As you can see, this is a point A and this is the point B. Pressure at A is PA, pressure at B is PB. Now first of all, here pressure below, line XX, as you can see in the diagram. Pressure below line XX in left limb, left column. Here limb is your column. So left column is first pressure, that is PA. Now here the sign is negative because it is going opposite to the gravitational force. So PA minus, remember, PA minus rho 1 G H1. This is a pressure on XX in left column. Okay. Now pressure below XX in right column, that is PB. First pressure due to center of the pipe, that is PB minus rho 2 G H2, that is due to liquid in pipe B, rho 2 G H2 minus rho S G H. Clear? So comparing above equation, because pressure at left side equals to pressure at right side. So comparing these two equation, so PA minus rho 1 G H1 equals to PB minus rho 2 G H2 minus rho S G into H. Okay. So making PA minus PB is your subject, that is a pressure difference between two pipes, is rho 1 G H1 minus rho 2 G H2 minus rho S into G into H. So this is the final equation to measure pressure difference between two pipes with inverted U-tube differential manometer. And remember two things here, that manometric fluid in inverted U-tube manometer is always lighter than water. Normally we are taking oil or kerosene. And second thing, inverted U-tube manometer is used to measure low pressure difference. Okay. So done for the today. Now the remaining topics we will discuss in our next lecture. Thank you.